Hey everyone, my name is Ikram and today I will talk to you about the derivatives of inverse functions. So, what's an inverse function? It's a function that ungoes or just in case inverts the effects of the function effects. We all know from pre-calculus that if y is equal to the x, what will be the inverse of it? It will be y is equal to ln x. How to define? Let us go over it. To find the inverse, we just replace x and y. It becomes x is equal to e to the y, and now our job is to find the y. How do we do that? That's an interesting question. We just write ln to the both parts. There is a sticker that shows that calculus is fun, and it becomes ln x is equal to y, because ln e is equal to 1, and y comes to here as a coefficient, so y is equal to ln x. It is the inverse of the first function. If we graph this, there will be an interesting graph. Let's first graph e to the x. It has a horizontal asymptote when it goes to the negative infinity. And when we graph ln x, we notice a very interesting thing here. It is symmetric to the function y is equal to x. That means that these functions are inverse. I will note one more interesting part of this. When ln x function gets 1, it's 0, because ln 1 is equal to 0. But there's a number between 2 and 3 where ln function gets 1. That's a number that we call e, which is in other chapters. And also, interestingly, there's a number after between 2 and 3 that's called e, where this gets 1. So you see how it works. This function gets the values 1, e, but this function gets the values of e1. That's how inverse function works. Now let's practice something. We have, and we are given a task. First, find its inverse. Second, find their derivative of inverse and the actual function and compare them. Okay, we can do that now. Let's first find this derivative. It will be y is equal to 1 over 2 because it's a constant and 1 over 2 stays as a derivative. To find the inverse, we know how we do it. We just replace x and y. It gets x is equal to 1 over 2y plus 1. 2x minus, isn't it? So this will be the inverse function. So what will be the derivative of inverse? It will be 2, because there's just a constant times x. There's one very important thing about this. As you see, these are reciprocals of each other. What does this show? The slopes are in the, let's say, n and 1 over n. That's an interesting rule that people who studied DIM know, but probably some do not know the reason of it. I will share with you something that I have learned while preparing. Inverse function is commutative. What does it mean? For example, a and b, a times b, is equal to b times a. This is commutative because order doesn't matter at all. And how do we implement this here? We get f of f negative 1 x is equal to x. Or basically, the order doesn't matter. fx is equal to x. I would like you to understand it in a more easy way, rather than math. We have a point x. F of x is a nice function. It says go 5 points in front, go 5 steps front. But there's also an inverse of it, f negative 1x. It says go 5 steps but backward. So what will happen? It goes, both are in respect to x in each. It's 1, 2, 3, 4, 5. This is, we call fx. And what happens when we call f of -1 of this? We are here right now. It goes 1, 2, 3, 4, 5. We go to the same point x. As you see, we called first the fx function and called f prime of the same function, we get x. And of course, because it's commutative, this is true as well. So you will get a very interesting formula with the help of this. Now, I challenge myself and you to find the derivative of both sides with respect to x. What happens? Of course, from chain rule, we know we first find this and then derivative of inside. It's f prime f of -1x times f of -1 inside derivative x. I will write it in an easy way. So it's like this equals to 1 because derivative of x with respect to x is 1. Now let us find the derivative of inverse function. We actually already proved it. Derivatives 1/2 are the inverse of each other, not the inverse, the reciprocals of each other. We already proved it. But now we have it in the formula of theory, which can be remembered very easily. And derivatives of inverse and the function itself are reciprocal. Now let us solve one last question to understand it even better. Let us find its derivative, its inverse and its derivative. What will be its inverse? We replace y and x. Okay, we got it. Oh, sorry. Yes, 3/2. Let's find the y derivative. It will be 1/2. Y -1 derivative. It will be 1/2. How can we find it in the formula? We have that f -1x with this is equal to. What is f -1x? It is this. The derivative of f of x is always 2. So we just replace it 1/2. So it's reciprocal. Again we prove. So what did we do today? Today we learned about inverse functions and how their derivatives can be found. On the last and in a nutshell, I want you to understand it in an even funner way. We have a ball. It's f of x. Now we called it. It's enough. It's towards us. Now let's call it. F of x goes as a function to there. But now comes the f -1x. Here. And inverse functions are an important part of calculus that we all love. Thank you very much.